Assalamualaikum. We're going to present a project which is diabetes prediction. I'm Ishwat Sahin, and here are the others members' name and ID. So the table of contents we are going to cover are introduction, data description, data preprocessing, dataset splitting, model testing, model selection, and conclusion. Let's start. We know that nowadays diabetes is a serious issue that affects millions of people worldwide and also lead many serious health issues like heart disease, kidney failure, blindness, and amputation. That's why we need to find out early detection and prevention way to fix this problem. But the analysis of diabetes is in many cases in view of blood glucose estimation, which are obstructive, expensive, and tedious. Besides, blood glucose level can differ contingent upon different factors like eating regimen, exercise, stress, and medication. So we are going planning to make an artificial intelligence model that can foresee diabetes in light of clinical and segment information. We will utilize a dataset of 1 lakh patient with some elements like age, orientation, BMI, hypertension, HbA1c, and glucose level. We will investigate different AI calculation and think about their presentation and precision. We will likewise convey our model as a web application that can take client inputs and give diabetes expectations. Our motivation is to develop a simple, low cost way to predicting diabetes. We want to make the prediction method non invasive so it does not need any needles or invasive procedure. We also want to use artificial intelligence to make the predictions more precise and dependable. By detecting these signs early, we can help stop the onset of diabetes and its complications. Our approach not only aims to enhance the precision of diabetes prediction but also to enable individuals to take charge of their health. We want to improve how patients handle their own health and how healthcare is provided over diabetes, making it more reachable and efficient. This way, we hope to help with the early detection and prevention of diabetes, leading to better overall health outcomes. Data description. Here's the link of the dataset that we use. The dataset that contains medical and demographic data for pretending diabetes. It has 1 lakh rows and 9 columns. This dataset consists of different attributes that capture different elements of prediction. There are total 7 features by which we can do our prediction. It's framed as a classification problem because in the context of diabetes prediction, the task is to classify individuals into two categories, those at risk of developing diabetes and those not at risk. Here's the list of the potential features present in the diabetes prediction dataset. Age, hypertension, heart disease, BMI, HbA1c level, blood glucose level, and diabetes. Here's the correlations. Here we can see the information about percentage of diabetes, here diabetes, hypertension, blood glucose level, heart disease, etc. It will help us to understand dataset and find out any faults if it is there. So here's the code.
So here in the data processing part, we are preparing a raw data for analyzing by transforming it into more efficient form and more which is more reliable. It makes the data more trustworthy and suitable for analysis. One thing before starting it, one thing to keep in mind that we are not using any null values here. We are just it's not applicable for running any null values. So here we have some categorical data. To handle those categorical data, first of all, we are taking the data for a person's age, their hypertension, heart disease, BMI, and blood glucose level, their gender, and their smoking history as well. Also, we are taking it in integer value. And since some of the data are categorical, we cannot express or represent those value in integer. So we have to remove those uh, the values that we cannot represent in numerics from the group. So for instance, we are removing gender and smoking history from the group. That's and further we are working with the rest of the data to predict the diabetes after removing those data which cannot be described or represented in the numeric values.
This section of our project is called feature scaling. Here we use standardization. In standardization, the values of the features are transformed to have a mean of 0 and a standard deviation of 1. Here we call this standard scalar function. It is the implementation of standardization. And then we call fit. Here it computes the mean and the standard deviation of each feature in the training set of X. Then we call transform. It transforms and standardizes the features using in the computed mean and standard deviation. Standardized characteristics are present in the X matrix, and this standardized data is used to train the model. After that, we split the dataset into two parts. These are the test part and the training part. Here, test variables are X test and Y test, and train parts are the X train and Y train. In this section, training set, the training set is used to train our machine learning model containing a portion of the original dataset, and the model learns the patterns and relationship within the data. X train, X train represents the features input variable of the training set, and Y train represents the corresponding levels or target values for the training set. Here, an individual has diabetes or not is the Y train. 0 means the patient or the individual doesn't have diabetes, and 1 means the individual has diabetes. In this code, Y is the target variable here, indicated whether an individual has diabetes or not. Test size is 0.3. It specifies that 30% of the data will be used as the training set, and the remaining 70% will be the training set. Stratify Y ensures that the distribution of the target variables is preserved in both the training and testing sets. This is important, especially when dealing with imbalanced datasets. Here, uh, we declare random state as 0. It sets a seed for the random number generator, ensuring reproducibility. The same seed will result in the same split every time the code is run. By splitting the dataset into the training set and testing set, we can train our model on one subset and evaluate in performance on another, helping us to predict how well it is going to perform on new and unseen data.
Hello everyone, I am Tasnim Habib. My ID is 22101139. And in this presentation, I'm going to represent very two important topics for our project, which are model training and testing, and the other one is model selection and comparison analysis. So in the model training and testing, we have taken four very important models, which are SVM, KNN, logistic regression, and naive Bayes. What we try to do is we try to find the accuracy, precision, and recall scores by coding these models. Here you can see in the code for SVM model, we can see that we have called the SVM, and here we have tried to use the predict function by guessing how many times it's going to predict the right answer, the model. And then again, we took that prediction value into a variable, and we transferred that variable into the accuracy score, so that our model provides the accuracy score for training and testing data. And same thing we did for the other three models as well. And then we tried to plot a confusion matrix using precision and recall function. Here in the confusion matrix, we can see that compared to the right prediction, the wrong prediction is much lower. And it's the same for the rest other models as well, except for KNN. And that's because if we try to compare these models, then we can see that the naive Bayes model has the lowest accuracy rate, which is around 0.9. But if you look closely to the other three models, we can see that among these three models, KNN has the highest possible accuracy rate. So if we are about to find any possible results, then among SVM regression and KNN, the KNN model is going to provide us with the highest accuracy rate, which is near 0.9609. So that was it for me. Thank you for listening.
So to conclude, in this project, we developed an AI model that can predict diabetes based on the medical and demographical data. We used a dataset of 1 lakh patient, and with adding 7 features. Also, we such as the features are their age, gender, BMI, hypertension, heart disease, smoking, and glucose level on the blood. So we implemented some of the algorithms here. So for instance, and those algorithms showed some accuracy level. For instance, our result showed that the support vector machine, which is known as SVM, achieved accuracy of 96.04%, this SVM part, and the naive bias having the accuracy of 90.3% after applying the algorithm. Also, we applied the logistic regression algorithm, which showed the data for 96.004%. So our model outperformed some of the existing models for diabetes predictions that used the same or the similar data set. Our web application provided a user-friendly interface, obviously, which showed some of the data as well, and received prediction result with confidence score. So here is some of the graphs that showed the accuracy level. So, like, to conclude it, our project demonstrated how AI can be applied to a real world problem and provide valuable insights. Our model can help healthcare profession identifying patients who may be at risk of developing diabetes, or it's also like reduced a lot of human work. It's like available for everyone. Anyone can use it and implement it. After implementing it in their lifestyle, they can be more concerned about their health, about their glucose level in the blood, so they can have a proper diet and every other things related to the diabetes, increasing the rate of diabetes. So additionally, our model can help individuals in monitoring their own health, taking preventive actions. Our project also contributed to the early diagnosis and prevention of the diabetes, and ultimately leading to a better overall healthy outcomes. So that's it from our group. Thank you so much.